Hey guys, welcome to Unit 6, Lesson 6. Our topic today is differentiability. So here, the warm-up is given to you. I want you to pause the video and try the warm-up. The warm-up says match the graph of the function with the appropriate graph of the derivative. So anytime you are looking for the graphs of your derivative, I'm going to say two things. Look for where m is equal to 0, where its slope is 0. And then look where it's increasing and decreasing. If it's increasing, it's going to be above the x-axis, the derivative will be. The derivative's graph will be above x-axis. And if it's decreasing, the derivative graph is below x-axis. So that's how it's going to help you find out the answers. So here, look here. First, I'm going to start with finding the slope. Here my slope here is what? 0. Here my slope is 0, so all of this, it's 0 here and here. My slope m is equal to 0 if you want to write that. I'm going to color code it. And where is this 0? So this is 0. So if I look at this, like the obvious one that I look at here is it has how many zeros? It'll cross the x-axis at 1, 2, 3, 4. And over here also, it's 0. 5 points. So which one crosses the x-axis at 5 points? 1, 2, 3, 4, 5. So it's only this one. So choice 3 would be D. So this would be here. I'm just going to draw the arrows. Okay. So now this one has 3 zeros. So which one has 3 zeros? Or crossing the x-axis 3 times? It's only this one. I didn't even have to look whether my graph is increasing or decreasing, but you can go ahead and check. Now we're left with these two. So look here. For these two, both of them have a slope of 0 and they're both crossing the origin, so it really doesn't help. From here, if I read my graph, this is what? Decreasing, and this is what? Increasing. Look at this graph. It's increasing all the way, so it has to be above the x-axis. This whole graph will be above the x-axis, so it is choice A, and this will be choice B. Look here, it starts from below the x-axis, graph is below, it hits the origin, and then differentiability. A function may have a left-handed and or right-handed derivative similarly to the way a function has a left-handed and right-handed limit. In order for the derivative to exist at a point, the left and right-handed derivatives must be the same. So it's just like how we look for the limits whether if the left and the right are same, it exists. Same thing is with the derivatives. So let's get started with the example. It says, do each of the following functions have a derivative at the given value? In order to check for a derivative, you must know that the function is, you must check for continuity. So the first one is a piecewise function, so I'm going to check whether it's continuous at 1 or not. So how do we do that? My first function is, I'm going to actually zoom in. So f of x equals, this looks really messy, I'm going to rewrite it. F of x equals x squared, so I'm going to find f of 1. That's how you do it. 1 squared is 1, so it's 1. So I got 1 for this function, and I want to say 1 for this function, and what do I get for the other one? My function is 2x minus 1. I'll substitute in 1. So 2 times 1 minus 1 is what? 1. I got the same values, so what can I say? F of x is continuous. So I checked for continuity. Now I'm going to find the derivative of these. So I'm going to actually use my difference quotient to find the derivative. So this would be, I'm just going to take it here. M equals limit as h approaches 0. I'm going to do what? I'm going to, it would be x plus h squared, which would be x squared plus 2hx plus h squared minus x squared over h. The x squares cancel out. I'm going to factor out the h, right? So I'm left with what? 2x plus h over h. My h cancel out. I did skip a few steps here. I'm sure we all understand this by now. So I'm going to apply the limit in this step so I don't have to write that limit definition. So it's going to be 2x. So that is my derivative for the first one. I can write m, or we've been using the derivative, so I can write f prime. I would rather write f prime of x. F prime of x, or derivative of x, is this. So we got that. Now we want to find the derivative of the other one. I'm going to use the color blue. So f prime of x of this. So you're going to substitute so I'm going to do limit as h approaches 0, and this is what, 2 times x plus h minus 1 minus, I'll do what, 2x minus 1 all over h, right? So I'll distribute it and then simplify it. Limit as h approaches 0, this would be 2x plus 2h minus 1 minus 2x plus 1 over h. What happens to my x terms and my 1 term? They all cancel out. I'm left with what? 2 over h. The h's also cancel out. Don't they cancel out? So I'm left with what? 2. Limit of a number is just a number. So it's 2. Oops. Just gonna. So now, if I do f prime of 1, that's what I'm checking, right? If it's differentiable at this point. f1, it's 2 times 1 is 2. For this, it's going to be 2 all the time, which is same. So yes, it is. It has a derivative. Has a derivative. At x equals x equals 1. So that's what it is. So now similarly I'm going to do b. First I'm going to find if it is continuous, and then from there I'm going to find if the derivative exists at 0. So to check for continuity, we can just substitute in here. So what do I get? I get, my first function is g of x equals x squared. So I'm going to do g of 0. I get 0 squared, which is just 0. So g of x for equals 2x. That's my second function. So g of 0 would be what? 2 times 0 is 0. You got the same output. It's the same value. Therefore, g of x is continuous. Right? So now I want to find if it's the derivative exists. So first I want to find the derivative. I already did the derivative of this in the first question, so I'm not going to repeat that. I'll just draw a line here, and I'm going to write it in. The derivative of x squared is 2x. Right? We did that here. Right here, you can copy all that work from there. And so the at 0 it will be what? 2 times 0 is 0. I'm going to similarly find the derivative of 2x. So I'm going to use my difference quotient. Limit as h approaches 0, 2 times x plus h minus 2x over h. So this would be limit as h approaches 0, 2x plus 2h minus 2x over h. The 2x's cancel out, and the h's also cancel out because it was 2h over h. So I'm left with just what? 2. So at f of 0, this would still be 2 because it's a constant. Always will be 2. Always. I'm going to just write that down. So what can I say? these values are not the same, I should write f prime of 0. So the derivative does not exist. So let's write that down. The derivative does not exist at x equals 0. There are 4 different instances where a derivative will fail to exist. We saw 2 examples right now where one it did exist and the other it did not. So continuity does not mean that the derivative would exist. So you have to check. What's the first one? Whenever you have a corner, I'm going to just circle it. This is a corner here. It's an absolute value function if there's a corner. So there is no derivative, although it's a continuous function, right? So there is a corner, so the derivative fails to exist. Over here, it's called a cusp. It's not like, it's like an arches on either sides. And then this one's very important. This is a vertical tangent. Think about it. Derivative is slope. What is the slope of a vertical line? It's undefined. It does not exist, right? So that's where it is, a vertical tangent. Vertical tangent is not same thing as vertical asymptote, because vertical asymptotes means that the function is not continuous. Vertical tangent means the function is continuous, but the derivative does not exist. So I want you to be very clear about both those things. And then if you have a certain kind of discontinuity, any kind of discontinuity, here it's a jump, so all the discontinuities, the derivative does not exist. So let's move on to the next page. So I just want to sum this up. Differentiability implies continuity. If f has a derivative at x equals a, then f is continuous at x equals a. So if you have a derivative, it means it's continuous at that value. But if f is continuous at x equals a, does not guarantee, so please remember, continuity does not guarantee that you have a derivative. So please be very careful about it. So now I want you to finish the remaining lesson. Good luck.